Logarithms are a crucial topic in most high school curriculums, yet many students face a lot of difficulties in this topic. So today we'll be going through a basic introduction to logarithms. Before we begin, if you're a low-income student and would like personalized tutoring, make sure to check out the link in the description. So let's first clear up the definition of a logarithm. A logarithm, or log in short, is the power to which a number must be raised in order to get some other number. In other words, a logarithm answers the question, how many of this number do we multiply to get that number? Now let's look at this through the lens of math. Let's consider an exponential equation, b power x equals y. Here b is the base number and x is the power to which b is raised to. The logarithmic form of this equation would be log y to the base b equals x. Now let's look at some examples for better understanding. In the first example, the exponential form is 2 power 4 equals 16. The logarithmic form is log 16 to the base 2 equals 4. As you could see here, the base number 2 is same as the base of the logarithm 2, and then the power to which 2 is raised to, here 4, same as the answer here 4. So now let's look at another example. Here the exponential form is 5 power minus 2 equals 0.04, and the logarithmic form is log 0.04 to the base 5 equals minus 2. Here again base number here is 5, and then the base of the logarithm here is 5. The power to which 5 is raised to is minus 2, and then the answer here is minus 2. So now let's look at solving basic logarithmic equations. Let's start off with a simple example. Log 125 to the base 5 equals x. So as you can see, this equation is in logarithmic form, and we need to, the first step would be to convert it into its exponential form. In its exponential form, as we discussed above, the base of the logarithm is the base number. So here the base of the logarithm 5. So the base number would be 5, and the power to which it's raised to is x, is the answer, which is x. So we get 5 power x equals 125. And we know 125 is nothing but 5 power 3. Thereby we get x is equal to 3. So now I recommend the viewers to pause the video and try to solve log 32 to the base 2 equals x and log 81 to the base 3 equals x on their own. So now let's look at the solution to these two questions. So the first question, log 32 to the base 2 equals x, again is in logarithmic form and we need to convert it into exponential form. So as we know, the base number here is nothing but the base. The base here is nothing but the base number. So 2 is the base number of the exponential form, and then the answer here is the power to which is raised to. So 2 is raised to the power x. So we get 2 power x equals 32. And we know 32 is nothing but 2 power 5. Thereby x is equal to 5. So now let's look at the second question. Log 81 to the base 3 equals x. So again the base, it's in logarithmic form, so we have to convert it into exponential form. So the base here is 3, so that means the base number here is 3. Answer here is x, so that means it's raised to a power x. Thereby we get 3 power x equals 81. We know 81 is nothing but 3 power 4. Thereby x is equal to 4. So now let's look at types of logarithms. So there are two main types of logarithms. The first one is common logarithm. Logarithms of base 10 are called common logarithms. They are represented as log 7, log 25, etc. These in default have base 10, and the base 10 does not have to be explicitly mentioned. So if you come across anywhere such log 5, log 30, etc., these logarithms in default have base 10 and the base 10 is not explicitly mentioned. So now let's look at natural logarithms, the other type. The logarithms of base e are called natural logarithms. They are represented as ln 7, ln 25, etc. ln is the abbreviation of the Latin form of natural logarithms. All these in default have base e, and the base e does not have to be explicitly mentioned, similar to common logarithms. So thank you guys for watching this video, and I hope you found this video helpful.